Welcome to The Explainer. Today, we're going to take a fascinating look at the foundational logic of modern computing. We're completely stripping away all that complex jargon to look at the elegant, surprisingly simple logic that makes everything sitting on your desk actually tick. So let's get right into it. Okay, let's dive into this. Here is our agenda for today. First, what exactly is a computer? Second, various types of computers. Third, the main parts of a computer. Fourth, input and output. And finally, some key things to remember. Section 1. What exactly is a computer? Let's demystify exactly what this machine is built to do. At its absolute core, a computer is simply a really fast electronic machine. It takes data in as input, processes it, and then spits out a result as output. Seriously, the magic isn't in some mysterious mechanism, it's just in the fact that it operates as a lightning-fast calculator, handling massive amounts of data in literal milliseconds. So this core definition actually translates into a very specific continuous workflow. Every complex action a computer takes boils down to just 4 fundamental tasks. Step 1, it takes input. Step 2, it processes the data. Step 3, it stores the information. And Step 4, it gives you an output. It's basically a repeating rhythm. 1, 2, 3, 4. Section 2. Various types of computers. We're going to see how these machines come in different shapes and sizes depending on what we need them to do. Now, what's really interesting about this slide is that while that 4-step rhythm remains exactly the same, the physical forms have completely evolved around our human needs. We started with the desktop, right? Those stationary powerhouses for our offices and homes. But then we demanded mobility, which gave rise to the battery-powered laptop. And eventually we prioritized pure convenience, leading to the tablet, a neat touchscreen hybrid that just ditches the physical keyboard entirely. But hey, the ecosystem doesn't just stop at our personal devices. Supercomputers are literally the heavy lifters of the planet. They run mind-bogglingly complex calculations for things like space research and global weather forecasting. Meanwhile, you have server computers, which act as the invisible backbone of the entire modern economy. Every single time you load a website, you're pinging a server designed purely to store and route all that internet data. Section 3. Main parts of a computer. Let's pop the hood and look at the physical anatomy of these machines. I want you to consider this fundamental biological metaphor. Just as a human brain thinks, the CPU runs the computer. It is the absolute ultimate decision maker of the entire machine. Without it, everything else you're looking at is really just, well, plastic and metal. So CPU stands for Central Processing Unit. When we call it the brain, we mean it quite literally. Processes all the instructions you give it. Behind the scenes, right at this moment, it's performing endless calculations, making lightning-fast decisions, and controlling every single other part of the computer. It is the absolute core of that processing step we talked about a minute ago. Now, to actually see what that brain is doing, we rely on the monitor. Acting a whole lot like your familiar television screen, this is the visual display where the CPU communicates its final processed output directly back to us, whether that's a boring spreadsheet or an amazing video game. To talk back to that brain, our primary tool is the keyboard. Sure, we use it for typing letters and inputting numbers, but more importantly, we use it for giving precise, instantaneous commands. We do this using important keys like Enter, Spacebar, Shift, Control, and Backspace. And working right alongside the keyboard is the mouse. Think of the mouse as your literal virtual hand inside the machine. It's a pointing device that lets you easily navigate the computer's digital environment. You're using it to click, open files, select text, and drag and drop items. And you do all this primarily using a left click, a right click, and that handy scroll wheel right in the middle to just glide up and down pages effortlessly. Finally, we have the printer, which acts as this incredible bridge between the digital world and the physical world. It takes what the CPU has just processed and renders it into physical output on paper. We're talking text documents and full-color photos, utilizing either inkjet or laser technology to make it happen. Section 4. Input and output. Let's see how all these pieces talk to each other. And this brilliantly illustrates how we can categorize all these components by a simple, clean divide. Input devices, like the keyboard, mouse, or a scanner, they are the computer's senses. It's how data goes in. On the flip side, output devices like the monitor, printer, or speakers,
Well, those are the computer's expressions. It's how the final results come out.
Let's actually tie this whole journey together by following just a single keystroke. Imagine you type a letter on your keyboard. That's step 1, the input device sends the data. Then, it shoots instantly over to step 2, processing, where the CPU recognizes the letter and decides what to do with it. Almost instantly, it pushes that data to step 3, the output device, and boom, that letter pops up right on your monitor. Input, process, output. It happens literally millions of times a second, but it always follows this exact path.
Section 5. Things to remember. Let's lock in these concepts.
So the crucial point is to lock this all in by memorizing these 5 basic associations. The CPU is the brain. The monitor is the screen. The keyboard is for typing. The mouse is for control. And the printer is to print. Grasp these pairs and you truly understand the core logic of any computer on Earth.
Well, that brings us to the end of our explainer. But before you go, I have a quick challenge for you. Based on what we just covered, what kind of computer are you watching this on right now? And more importantly, which of its exact parts are acting as your input, and which are your output at this very second? Think about it. Thanks for learning with me today, and I'll see you in the next explainer.